As an exercise, you will be required to compile the code yourself. Detailed steps will be provided for you to do this successfully. Start by typing the code used for the first example into a file in Pico and save as myfirst.c. Pause the video and restart once you have saved the file. Now, to compile the program, type the following into the Unix environment. Note again that you have to be in the same directory as the file. Again, pause the video to try this. Before continuing, we will explain what it is that you just did. The first part of the line, GCC, indicates that we will use a compiler called GCC. The next three arguments, all preceded by a dash, are called flags. These flags are instructions for the compiler. In this case, we are using the flags WAL, which outputs every possible warning that the code might raise, and WError, which turns all warnings about compiling the code into errors. Warnings are usually present to indicate constructions that are generally considered questionable and are easy to correct. LM simply links the mathematical library to your program. Next is the name of the file you wish to compile. Lastly, -O specifies that you will have an executable, and this executable will be called myFirst. Note that myFirst is different than myFirst.c. One is the program, the other one is an executable file. Executable files do not have to be named the same as the original .c files, but it might be easier to keep track of them this way. Also, if you omit this last instruction, you will simply get an executable file called a.out. The last thing left for you to do is to run the executable file. To do this, type the following into Unix. Pause the video and come back when you are done. Now you should have seen the program running. Note that Unix is still not available to you. You will need to hit Enter to go back to Unix after running this executable. The reason for this is the getchar statement.
Rewrite the previous code but this time without the getchar function. Save as mysecond.c and compile. Name the executable mysecond and run the program. Pause the video and come back when you have done this. Did you notice how the program does not stop after it finishes its time? This occurs because there is not a function waiting for the user to hit enter. You may find this useful in some applications.
Now, we will explain other details that are important for C. In C, variables need to be declared just as functions are declared. Details on function declaration will be seen in later modules, so for now, we will focus on variable declarations. Before we use a variable, we must first indicate what type of variable it is. This action is called declaration of variables. Note that a variable cannot be used in any way until it has been declared. Variable declarations have to be made at the beginning of the code, before anything else has been written. To declare a variable, we first specify the type, as indicated here. The basic types are shown here: int, for an integer; float, for any real number; double, for any real number with high precision; and char, for both single characters and character arrays or strings. At this point, we can initialize a particular variable as shown here. Also note how we can specify the size of character arrays or strings.
Before continuing, let's review some of the rules and details about data types and variable declarations. We first identify token as a language element that can be used in forming higher-level language constructs. C has 6 different kinds of tokens, but we are particularly interested in only the first 2, keywords and identifiers.
The first token of interest is reserved words. These are keywords that identify language entities, such as statements, data types, and language element attributes. They have special meaning to the compiler and as such, may not be used as programmer-defined identifiers. The following list contains some of these keywords.
Identifiers are names for program variables, functions, and other program constructs. Any word that is not a keyword can serve as an identifier. However, there are certain rules that need to be accounted for. 1. Identifiers must consist of only letters, numbers or underscores. C is case sensitive. 2. Identifiers must start with a letter or underscore. 3. In general, there is no length limit, might be compiler dependent. However, most C compilers only recognize the first 32 characters as significant. 4. Identifiers must contain no embedded blanks. 5. As mentioned before, reserved words cannot be used as identifiers.
Identifiers need to be a certain data type. These data types are summarized here. The integral types include the char, or character, and int, or integer. These also have the short, long and signed, unsigned variations which are used for more specialized situations. For example, short and long are used when storage memory is of concern, since short usually requires less space in memory while long usually requires more memory to store large numbers. Similarly, the unsigned types are specialized cases because the distinction between negative and positive values is not of importance. These differences are relevant again when memory space is of importance. It is important to understand these differences, and it will be left to the student as an exercise in a later module to investigate how these types are different. For most examples, we will focus on the basic char and int types. Similarly, the floating types include float, double, and long float. Float denotes a floating point number, or a number with digits after the decimal point. Double denotes a float with double precision, that is, larger memory space requirements due to the extra digits it stores. While float stores up to 6 decimal places, the double type stores up to 15 in most computers. Again, this is of relevance mainly for specialized cases. Another data type of relevance is void, which denotes a valueless type. Newer versions of C have other more complex types, but we will not be covering those here.
As mentioned before, all variables, as well as all functions, need to be declared to be a particular data type.